and your hypothesis is going to be this. The winter time is equal to the probability that a player will be born in the spring, which is equal to the probability that a player will be born in the summer. That's your null hypothesis. And of course, if one of those p's differ, at least two of them have to differ, but that's the alternative hypothesis, at least one of them is different. So let's look at our expected values. All together, when you add them all up, there are 450 players. So since all these are the same, the expected value is the same for each of those, it's going to be 450 times 0.25, or divided by 4, which is 112.5. So the expected value for each of those is going to be 112.5. I'll show you a quick way to do this on the calculator. Doesn't sound quick. Okay, so let's put all those original numbers. We'll put the observed values over here in list 1. 112, 113, 105, and 111. Oopsie. Now we'll put our expected values. And then list 3, this is really kind of slick. Watch what I do, and you can see what I do down here. I'm going to take the observed minus the expected. I'm going to square that, and then I'm going to divide it by the expected value. So all of these is the observed minus the expected squared divided by the expected. Pretty slick, and you can see a lot of these are really close to 0.25, so these numbers get really, really small. So let's look at that let's look at the sum of that. So I'll quit, clear, now watch this. I'll hit second, and then list, and then I go over here to mathematics. And one of the things that you can do is you can add up everything in a list. So I'll do the sum of that last list that I just made, list 3. And real quickly, I found the sum of the observed minus the expected squared divided by e. That worked out to be 0.52. That doesn't seem very big at all. And in fact, when we compare that with chi-square, 0.524 is going to be way down in there, and so we're going to have to fail to reject the null hypothesis. The critical value for this, where n is equal to 3, there are 3 degrees of freedom. Go to my chi-square table, sorry about this. With 3 degrees of freedom,